Good afternoon, everyone, and welcome to our lecture series. So, for today, we will focus on topics in advanced and college algebra, and specifically, the topic that I'm going to discuss for today is on algebraic expressions. So, yeah, I'd like to welcome you all to our lecture series. At the moment, I only have 3 viewers. So, if you just tuned in or if you just joined me, welcome to our lecture series. Okay, so let's start. So, for today, we're going to discuss about algebraic expression. Okay. And before we go further, let's um, get familiarized with some of the important terms and definitions in algebraic expression. And of course, we start with the definition of what algebraic expressions are. So when we talk about algebraic expressions, it's a combination of a number symbol with the four fundamental operations. So for examples, 3 uh, x squared plus 2. We have x divided by the quantity x plus 5, the quantity x plus 1 times the quantity x minus 5. These are all examples of algebraic expressions. Now, we also have term. Okay, an algebraic expressions has a term or terms. So each distinct part together with its sign of an algebraic expression is called a term. So for example, we have an algebraic expression 3x squared minus 5x plus 1. Here, 3x squared, negative 5x, and positive 1 are terms. Okay, so we have, in this case, 3 terms in the algebraic expression 3x squared minus 5x plus 1. Okay, so we proceed to constant. A constant is a specific value of specific element of the set of real numbers. So for example, the real number 2, 7.1, 1/2 are constants. So given an algebraic expression, for example, 2x plus 3y, 2 and 3 here are constants. So we call them constants. Another example, 4x plus 9y minus 3. The constants here are your 4, 9, and negative 3. In our third example, we have 3x squared y minus 2xy plus xy squared. So the constant in this expression are 3, negative 2, and positive 1. Now we move on to variable. A variable is a symbol or a letter to represent any number. The value is not fixed. The word variable takes its root from the word vary, which means the value changes. So, example, the letters x and y in 2x plus 3y are variables. It means that the values of x and y may change. They have varying values. All right, so another example would be 5a squared minus 2c. So your variables there are a squared and 2c. So those are your variables. Now we move on to factor. So if a, b, and c are integers, then a and c are factors or divisors of b if b is equal to ac, b is called a multiple of a and c. Now we can illustrate this with an example. So here, 3 and 5 are factors of 15 since 15 is equal to 3 times 5. So we say that 15 is a multiple of 3 and 5. That's what we mean by factor. Then we also have here our coefficient. It's any factor of a term. It is a quantity multiplied to a variable or a quantity multiplied to a constant number that is being multiplied by a variable. So example here, if the given is 2x, 2 is a coefficient and x is also a coefficient. In algebraic expressions, the variable are literal coefficient while the constant are numerical coefficients. So in our example here for 2x, 2 is your numerical coefficient and x is called the literal coefficient. Another example, what is the numerical and literal coefficients of a given term 5x cubed? Of course, 5 here is the numerical coefficient of x cubed and x cubed is the literal coefficient of 5. Okay. Then in another example, we have the term 3x squared y. 3 is the numerical coefficient of the term, while x squared y is the literal coefficient of the term. So that's coefficient. Now we also have here similar terms. Two or more terms are similar if they involve exactly the same variables and the same exponents in these variables. So the terms 2x and 5x are similar terms, and likewise 3x squared y and x squared y, but 2x squared y and 5x squared y squared are not similar. Okay, so in other words, for them, for two or more terms to be called similar, they must involve exactly the same variables and the same exponent in these variables. So for example, here, 3x squared y, and this one is x squared y, so they are similar. However, here, they aren't similar because the x here is squared while the x here is not. It's the y that is squared in this term. So they are not similar terms. Combining similar terms, so in the algebraic sum, 5x minus 2x squared plus 3x plus 7x squared, the first and the third terms are similar terms, and the second and fourth terms are similar terms. So adding similar terms algebraically, we will get 5x plus, or 8x plus 5x squared. So when you are performing the operation, you can only perform an operation between two or more similar terms. So in this case, 5x and 3x. So 5x plus 3x would be 8x. And then minus 2x squared plus 7x squared will give you plus 5x squared. So if we are going to simplify this algebraic expression here, it will become 8x plus 5x squared. Okay, so those are the basics of algebraic expressions or expression. Now, when you are solving worded problems in algebra, it's really important that you know how to write expressions in verbal form to symbolic form or the other vice versa. Okay, that's very important in solving worded problems. If you find it really challenging to transform verbal problems into symbolic its symbolic form, then you'll find it really hard to solve problems in algebra or in any other math, okay, mathematics subjects, right? So let's just take a look at some examples that are words that are associated with the four fundamental operations. Okay, so here it says for addition, the sum of means you have to perform the addition operation, plus, more than, increase by, as many as, greater than, or from now. Okay, so from now means you're going to use the addition operation. For subtraction, difference of, minus, less than, fewer, decrease by, diminished by, ago. Okay. And then for multiplication, the product of, times, of, twice, we have triple, three times. Then for division, the quotient of, per, divided by, and this one should be a ratio. The ratio of 2 and 3. Okay. Now we also have here those that involves parentheses or parentheses. It's a combination of two or more operations times the sum. So for example, 5 times the sum of uh, x and y. So that would be 5 times the quantity x plus y. Then we have times the difference plus the difference of, twice the sum of, thrice the product of, twice the difference of, and so many. And so on. Okay, so many other examples here. Now let's take a look at an example, a lot of examples. Let's move this one below. Here, the product of a number and 8. Okay, a number means it's an unknown number, so you can actually assign any letter. Okay, for the word a number. So in this case, a number is represented as n. So the product of a number and 8 would be 8n in symbols. All right, so you can have 8a, 8x, 8t, 8l, 8m, doesn't matter. Then we have number 2, the sum of a number and 12. So a number again, and so since we talk about sum here, it involves the addition operations. So a number could be n, could be also a, b, c. So in this case, n plus 12. Okay, the sum of a number and 12 is n plus 12 or a plus 12 or y plus 12 or k plus 12. And then we also have here the quotient of a number and 9, the quotient of a number and 9. So that's n divided by 9. 15 increased by a number n. Okay, of course here we can write this only as 15 plus n because the unknown number is identified in this verbal description. It says here number n, so we make use of n. So this is 15 plus n. We cannot use 15 plus x here because in the verbal description, it made use of n. For number 5, 18 less than a number n. 18 less than a number n. Okay, take note here that we made use of the expression here, less than. Okay, so when you write this sometimes is uh, creating confusion among uh, students. When they see 18 less than a number n, they would write this as 18 minus n. But since you made use of the expression less than, this should be written as n minus 18. Now, when will this become 18 minus n? This will be 18 minus n if the given is 18 less a number n. So in this case, this is 18 minus n. So see the difference between less than and less? 18 less a number n, so it's 18 minus n. 18 less than a number n, it's n minus 18. So I hope you guys will take note of that. Then we have here 4 times the sum of x and 3. So obviously, it involves two operations here, like times means multiplication and sum is addition. So 4 times the sum of x and 3. So we will make use of a parenthesis. So this will be written as 4 times the quantity x plus 3. And verbally, or in words, that is stated as 4 times the sum of x and 3. Okay. Then we have here n decreased by x. So that is simply n minus x. Y doubled. So it's 2y. Okay. Be careful here. Y doubled is when you double it, meaning you multiply it by 2. You do not raise it by 2 because raising a number by 2 is not doubling the number all the time. Okay, for example, well, you might argue that 2 squared is doubling 2 because that is 4. You are correct there. That's why I said not all the time. But in the case of 3, if you double 3, that's 6. So if you raise that by 2, it will be 9. 9 is not 3. You're not double. It's not a result of doubling 3, because when you double 3, it means it should be a 6. Okay, so be careful with the word doubled. Then we have 5 less y. So this is my earlier example. 5 less y is 5 minus y. 5 less than y is y minus 5. Then we proceed. 5 less than the product of 2 and 6. Of 2 and x. Sorry. 5 less than the product of 2 and x. So you have 2x, product of 2 and x is 2x. Since we made use of less than, so that's minus 5. Then we have number 13, the difference of x and 3 divided by 6. Uh, this is pretty easy, I mean. So x minus 3 all over 6. Then we have number 14. Move this one. 15 decreased by the quotient of a number and 3. 15 decreased by means minus the quotient of n and 3, so it's n divided by 3. Then we have 15, the sum of twice a number and 5. The sum of twice a number means twice a number, it's 2n. This could also be 2x, 2a, 2b, and 5 plus 5. 2 less than 1/4 of 5. Take note again of what is used here. It's less than. So 1/4 y minus 2. Okay, 1/4 y minus 2, because it says here 1/4 of y. Of is multiplication, so 1/4 times y minus 2. Okay, so I hope you guys will answer the exercise. Okay, do you guys have questions at this point? Okay, so we have a lot of comments here. Everyone's saying good afternoon. Good afternoon to those who just joined me. I Do you have questions so far? I'm gonna make this quick because I know you guys have other things to do at home, and unfortunately, this is the only time that my Wi-Fi is working well. Okay, during in the morning or around early in the afternoon, medyo hindi maganda yung ating Wi-Fi connection. Okay, so yeah, please bear with me. If you have other things to do, then you can just leave the live and probably watch it again. But if you would like to join me here live, then please do so. I would appreciate that. Okay, so do you guys have questions? Please let me know if you have. So I know that your connection is probably delayed, so I'm not expecting you to answer immediately when I ask a question because I know that the connection is delayed at your end. Okay, so I'm going to proceed now to polynomial. The word polynomial is originated from the two words poly, which means many, and nomial refer to terms. So polynomial means many terms. All right. A polynomial is an expression having several terms. It's a single term. It is a single term or a sum of finite number of terms. Okay. A polynomial is a constant or a variable with a positive exponent or a product of constants and variables of the form a sub n x to the n, where a is a subset of the real numbers and n, which is the exponent, is a subset of the natural number. Okay. I think we discussed about natural numbers. These are your counting numbers, which usually begins with 1. Okay, so here it says here R is a set of real numbers while n is a set of natural number. A polynomial of degree n has the form a sub 0 plus a sub 1 x to the 1 plus a sub 2 x squared plus until plus a sub n x to the n, where a sub n here is not equal to 0. Okay, should not, because if a sub n is equal to 0, then you don't have a polynomial here. Okay, examples and non-examples, it says here 3, 5x, 3x squared, 2x plus 3, 4x squared minus 6x plus 9 are polynomials, while x to the negative 1 or 1 over x to the 1 half or square root of x, square root of x plus 16, and 4xy squared minus 7 over y plus 3 are not polynomials. They are not polynomials because according to our definition, the exponent of x here in a sub n x to the n should be an element of the natural numbers. And we know that natural numbers are numbers that's are counting numbers. Okay, these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. These are integers which starts from 1. And in the given example here, x to the negative 1, n here is negative 1, and negative 1 is less than 1. Okay? So, hindi siya pwede. So, this cannot be a polynomial. A polynomial. Same is true here. We know that the square root of x written in exponent is x to the 1 half, and 1 half is that an element of natural numbers. The same is true here for xy squared minus 7 over y. We know that 7 over y when expressed in exponent is y. 7y to the negative 1. So that exponent is not an element of the natural number. Therefore, they are not polynomials. Okay. If an expression has a variable under the square root sign or in the denominator, then the expression is not a polynomial. Okay. All right. So yeah. So we have here polynomial is a sum of terms involving variables raised to a whole number with no variable appearing in any denominator. A polynomial is a finite expression constructed from variables and constant using the operations of addition, subtraction, multiplication, and taking non-negative integer powers. Okay, so that's what we mentioned based from the definition earlier. A polynomial can be written as a sum of a finite number of terms. Each finite meaning it terminates, it ends. Okay, each term consists of the product of a constant called the coefficient of the term and a finite number of variables, usually represented by letters, raised to integer powers. Okay. Now, when we talk about the degree of a polynomial in any variable, degree of a polynomial is the highest exponent of the variable in the polynomial. So if the polynomial has two or more variables, then the degree is the highest sum of the exponents of these variables among the terms of the polynomial. So for example, if you are asked the degree of 5, so for example, 5 is a polynomial, okay? All right, so the degree of 5 is 0, since 5 can be written as 5x to the 0, okay? And x to the 0 here is equal to 1. So the degree of 5 here in our example is 0. And then we have 3x squared. The degree of this is 2. This one. The degree of this polynomial is 2. Then we also have 3x squared y. The degree here is for x is 2 and for y is 1. So you have to add them. That's according to our definition. When the operation involving multiple variables is multiplication, then you have to add the exponents of the variables. So here, this is multiplication. 3 times x squared times y. So you have x squared and y here. So the degree of x squared is 2, and for y, or the exponent of y is 1. So 2 plus 1 is 3. So the degree of this polynomial 3x squared y is, of course, 3. Okay, another example. The degree of 2xy plus x squared y minus x squared y squared is 4. Now, here we have 3 terms. This term, this one, and the last term. So you're not going to add all the exponents of the 3 terms. What you're going to do is you determine the degree of each term, and whichever is the highest is the degree of the polynomial. So for this term, the degree is 1 for x, 1 for y, so that's 2. Here, 2 for x, y is 1, so that's 3. For the third term, you have 2 for x and 2 for y. That will give you 4. So 4 is the highest, so therefore the degree of this polynomial is 4. The 0 polynomial has no degree. Yeah, because when we talk about degree or the exponent, you will not obtain a value of 0 if you are going to raise a certain number, because any number or variable raised to 0 will be 1, and you will not have 0. Okay, so yeah, the 0 polynomial has no degree. A polynomial is a rational expression. So it's a rational expression itong polynomial natin, kasi we made mention that we cannot have uh, an exponent if it's for division. We cannot have a variable in the expressed in as a division, okay? Or as a quotient, I mean. Okay, that's why it's a rational expression, because for example, if you have x over y, that is no longer a rational expression. Okay, so we have types of polynomial. We have monomial, there's only one term; binomial, 2 terms; trinomial, 3 terms; then we have multinomial, has more than 3 terms. Then we also have homogeneous expression. It's an expression is homogeneous if the degree of each term is the same. If the degree of each term is the same. So we talked about degree earlier here. Okay, so we call them homogeneous expression if the degree of each term is the same. So in this example, polynomial expression, we have a cubed plus 2a squared b plus 7ab squared minus b cubed. So we have four terms here. The degree of the first term is 3. The degree of the second term is also 3 because this is 2 plus 1. The degree of the third is also 3. It's 1 plus 2. And the fourth is also 3. So all that four terms have a degree which is equal to 3. So therefore, we call them homogeneous expression of third degree. Okay? So we'll try this exercise here. Find the degree of the following polynomials. Okay, will you guys try letter A? Can you tell me if what is the degree of this polynomial? Kindly comment your answer. Of course, you can do this without solving. By inspecting them, then you can immediately identify the degree of the polynomial. Okay. Letter A. Anyone? May we have an answer for letter A? The given polynomial here is y cubed minus 5y squared plus 3y plus 8. That's 3. That's correct. Aaron or Aaron. Okay, 3. So we have here y cubed. This is the highest. Okay. The second term has 2. The third term has 1. The fourth term has 0. So 3 is the degree of the polynomial. Letter B. Okay. So Divina Grace also answered 3. That's correct. Let's try letter B. 7a squared b to the fourth plus 2ab cubed minus 8b squared plus 1. What's the degree of this polynomial? Six. Yes, Aaron is also correct. Is Aaron the only person listening to my discussion at the moment? And Davina, how about the rest? Okay, the rest is history. I'm kidding. All right, let's have letter C. So for letter B, the answer is 6. Here, a squared plus b to the fourth. So 2 plus 4 is 6. Okay. Letter C is, what's the degree of the polynomial expression C under letter C? That's 5 also. That's correct. So you have 3x cubed minus xy plus 2xy to the fourth. So the last term has the highest exponent, or highest degree, I mean. That's 1 plus 4 is 5. So the degree of that polynomial expression is 5. Okay? That's correct. So, yeah. First degree polynomials are called also Divina Grace Agkawili. Yeah, you also got the correct answer. It's 5. First degree polynomials are called linear polynomials. Second degree polynomials are quadratic polynomials. Third degree polynomials are called cubic polynomials. Fourth is quartic. And fifth is quantic. Okay, and so on. Okay. All right. So shall we proceed? Yeah, I think so. Looks like you guys are still there, lurking, probably. I think we only have 12 viewers at the moment. Okay, so let me just proceed to the evaluation of algebraic expressions, and then we'll continue tomorrow. Yeah, this is pretty easy. So when we talk about evaluation of algebraic expressions, okay, so for example, the value of the expression 4x squared plus 2y when x is 2 and y is -1 is, So what we're going to do here is we're just going to replace the values of each variable. So in this case, x is 2 and y is -1. So using the expression 4 times x squared would be 2 squared. It should be squared, sorry. Yeah, this is squared. Plus 2 times y, here is -1. This should be squared. Okay. Plus 2 times 1 is equal to, so 4 times 2 squared is 4, that's 16. And then we have 2 times -1 is -2. So the answer here should be 14. Okay, kindly check that in your modules. And then we also have here another example. We have the expression a squared plus b squared plus c squared all over b cubed. Now you might ask me, why do we have a variable in the denominator? Okay, since we are talking about expressions here, we're not talking about polynomial expressions. We're talking about evaluating algebraic expression. Okay, and a squared plus b squared plus c squared all over b cubed is an example of an algebraic expression. Okay. Then we have a is 1, b is -3, and c is equal to 4. So what you're going to do is to substitute these values to the corresponding variables in the given expression. So if you evaluate that, the answer is 26 over 27. Okay, you can verify that. Okay, let me see. I hope this is correct. Sorry. So -3 squared is positive 9. 4 squared is positive. This is cube, so this should be negative. Yeah. So the answer should be negative 26 over 27. Okay. That should be the correct answer. I'm going to leave the exercises to you. Okay, and then you're just going to submit that in our group chats. Chat room, I mean. Group chat room. Okay. So yeah. I think that should be it for this session. I know that you have a lot of things to do at home, so I'm not going to eat much of your time today. But I hope you guys will allot time tomorrow because I'm going to have another session for advanced and college algebra. Okay? So, yeah. Do you have questions before I go? Are there things that you'd like to ask me, or would you like to clarify something? If there's none, just let me know so we can end this discussion. So we're going to have another one tomorrow. Okay, so since you guys do not have questions, please don't forget to read the material which I just sent you. You focus in chapter 2 because that will be the coverage of your prelim examination. And I'm going to create another GC for the submission of the learning tasks because you need to accomplish the learning tasks or the activities and submit it, but in a separate group chat. So we're not going to use the chat room that we are using now. We're going to create another one for submissions only. All right, so since you guys don't have any questions, so let's call it a day. I'll see you again tomorrow. Thank you and have a great evening. Bye, guys.